Before we start the video, a large thank you to AZX, Caesar, Kyle, Alexander, and Starlight for their support on Patreon. I hope you guys enjoy the video. And a massive thank you to Halo Burner, Ryan Belland, and Fernando for their support to the channel this month on Patreon. You are all sincerely and greatly appreciated, gentlemen. I hope you enjoy the video. Hello everybody, today we're going to make it so we can not fire our bow without a clear line of sight, and we're also going to make it so we can retreat to a position after the character fires a bow. So let's go to AI character actions and open up the AI character attack action, and let's make a flag down here, a public bool for require clear line of sight. And you might want to make that false by default so you don't basically change the logic of all the other attacks you may have in your project. So let's go over to the combat stand state, and right where we have get new attack, right here below where we do the check for the angle and the distance, let's write some new logic. And we're just going to say if AI character.current target does not equal null and this attack requires a clear line of sight, then we're going to do a check. So I think we've used a line cast in this series before, but just in case that we didn't, it is basically a cast that starts at a point and tries to go to a second point. And if it's interrupted, it lets you know. So we're going to say bool line of sight is blocked is equal to false by default. And then we're going to do if physics.linecast. If I hover over this, it should give me a tooltip. Let's see. Whoops, go over it again. Let's see. Returns true if there is any clutter intersecting the line between start and end. Yeah, so if we start at the lock-on transform of our character, so the AI character that is, and then we project this to the lock-on transform of the target, which is why we need to have a target when we do this. And let's make it only check for environmental layers, because you can see here it can accept a layer mask. And we'll do that by using our world utility manager, and we'll just get a reference to all of our environmental layers. So we do world utility manager.instance.getEnviroLayers. So what this is going to do is it's only going to check for the obstruction on those environmental layers, not on character layers. Now, if it does return true, then we know our line of sight is blocked because it's hit something in between point A and B. So we use a line cast starting from the lock-on position, and then we check for the environment, and if it returns true, then we know line of sight is blocked. Now let's go to the character combat manager, because we can actually utilize this in more than one place. So instead of writing out the code again, what we can do is simply make a check that we can use in the future, perhaps for other things as well. And we can make a public bool has line of sight. And because of the wording of this function, we're going to change how the flags return just a little bit. So because over here we're checking for line of sight is being blocked, now we're checking line of sight. So copy all of this though and paste it over here. And what we can do is basically change this from AI character to character. I don't know why you might want this for the character player, but just in case, I put on the base class of the character combat manager. I know that I primarily use this, or actually the only reason I think I use this in my project is for AI attack calculations. But anyway, if the character current target is null, we want to return true because we have line of sight because we're not checking for anything then. Now if it's blocked down here, we want to return false. And if it passes all these checks, then we'll just return true. If you want to, we can still use this variable name here. We'll make some comments. We have line of sight, so if it returns true, then yes, we are able to see it. And then I can go and basically just over here on the combat stand state, instead of writing all this, we can say and has line of sight. And there we go. So if we don't have line of sight, we can say continue. So if the current target is not equal null, if this attack requires line of sight and we do not have line of sight, simply continue, skip this attack. Now back over here on has line of sight, I'm going to rename this bool to has line of sight. I'm going to set it to true by default. And then I'm going to simply return has line of sight here if our target is null. I'm going to set line of sight to false if it's blocked. And then in the last line, I'm going to simply return has line of sight. And that looks good to me. Okay, now on draw gizmos, if you really want to nail this point home, we can just show it in the scene view. It's always helped to have a visual representation. So what this does is going to draw something when we have the game object in view in the scene with gizmos on. I'm going to say gizmos.drawLine, and I'll start the line at the character combat manager's lock-on transform dot position, and I'll end the line at the target's lock-on transform dot position. And again, you need to check for a target, or else you're going to get an error if you try to run this and there is no target. You can also change the color of the line if you're into that, but I'm just going to quickly write this out and show you, just so you have a visual representation of what's happening. This stuff is really helpful to draw gizmos if you want to see different shapes and raycasts and stuff, so I highly suggest using this if you don't, especially if you're stuck and you don't know why something is not happening. So if the current target is null return, if I go into the game here now through the magic of editing, you can see I have the game paused, and you can see that this character is attempting to draw a line at me, but it's intersected by this post. So he shouldn't fire at me, and he does, so apparently I've messed up. Alright, I have a theory. So we're not clearing our attack when we leave the attack state, and that could have us in a perpetual state of basically having the ranged attack, and that will put us back to the attack state. So say current attack is equal to null when you reset the state flags in the attack state. We should have had that done previously, but I forgot, I suppose. And now, after he fires this arrow, he shouldn't hit me. Let's see. And he still does. Okay, so I've messed up somewhere else. And I'm realizing I forgot to tick require clear line of sight on this attack. Now, after he fires this arrow, he should not draw. And yes, he does not. Okay, cool. But if I walk back out here, he's going to draw the arrow, right? So see this? If I walk back in, he'll still shoot me. Now, Dark Souls does this too, I'm pretty sure. At least I remember some of the archers doing it. But if you don't want this, then I'll show you how to avoid this as well. We can utilize that new function we just made, and we have a coroutine that tells us when we can fire or release that arrow, if you recall. So go to your AI Ranger Combat Manager, go to that coroutine, and then all you got to do is make a check right here, and we can basically just say, and has line of sight, just after this distance from target and viewable angle check. Now, if you don't want to do this all the time, you can just make a flag up there that says check for line of sight, or you can directly reference your attack action from the attack state because it's a public variable. But regardless of how you do it, the outcome will be the same. If I go in here now, through the magic of editing, let's get him to draw an arrow and then try to shoot me. So if I walk back in, you can see he will not shoot. Now when I come out and this line cast is cleared, he should take a shot at me. Yes, there he goes. Alright, cool, that's working as intended. So the next thing we could do is get this guy to retreat after he takes a shot at me. So let's go ahead and write some functionality to do that. And basically what I want to do is calculate a position that's away from the direction of the target he has. So let's go to the AI Character Combat Manager, and we can put a function here because we can use this in some other areas perhaps. It's always nice to have the function on the base class or the just the general combat class in case other characters want to use it. So let's do a public vector3 get retreat position. Now, if we have no target, we should not be retreating, so we can say if AI character combat manager dot current target is equal to null, we can simply say return the AI character's transform position, or just transform position if it's on the same game object. So I'm just gonna make a comment: if we have no target, do not retreat. Alright, also a little fun to do challenge, if you're up for it, is disable retreating if you have an archer and they have the height advantage. Now you don't have to do that, but it is cool to do that so they won't leave their post, even if the character is just a few meters away if they can't reach them. So vector3 retreat position is equal to vector3.0, so defaultly we'll set it to vector3.0, but we're going to assign it right away so it doesn't matter. And then we're going to say retreat direction is equal to, and we're just going to do the same thing we normally do to get a direction, and minus our current target transform position minus our transform position, and then we're going to reverse that direction. So we're going to say retreat direction is equal to minus retreat direction. I guess I could have just got that direction initially. Anyway, after that we're going to set the y value to 0, so the height itself is 0, and then we're going to normalize the direction. And now what we want to do is get like a random amount of distance in that direction, and then from there we want to get a point, and from whatever point it lands on, we want to get a random point within that point's area. And that probably sounds like a mouthful, but just let me explain. It'll make more sense in a moment. So first, let's get a minimum and maximum value of the retreat distance from the AI character, okay? So picture this. A line draws away from them, away from their target. And we're going to have a minimum and maximum amount of that line. So it could be 5 meters away from them. It could be 20 meters away from them. But regardless, it's always in the same direction. It's directly away from the target that they're fighting. So you can maybe visualize that in your head. So let's do that by saying retreat direction is equal to retreat direction times random.range, minimum retreat distance, and maximum retreat distance. Now, once we have that line, what we want to do is imagine where that line ends. Now, wherever that line ends in your head, just visualize this. Picture a radius around it, like a circle, and we want to get a random point within that circle. So how do we do that? We want to make sure we can walk on with nav mesh too. It's very important, right? So we're going to say vector3 random position is equal to AI character.transform position plus retreat direction. And then we're going to say nav mesh hit And by the way, I did just make this on Nef, so if you guys find any problems with it, please let me know, because this has only been tested for a couple weeks now, but it's working pretty great from what I can see. So we're going to first get a retreat path, or make a retreat path, because we want to test to see if it's viable. So let's make a variable for that. Navmesh path retreat path is equal to new navmesh path. And then we want to use sample position. Now what does this do? Well, we pass a position, right? And we pass a radius around that position. So we have the position that we just made from our character, where we're retreating so many steps away in that direction. But now once we get to that position, we have to create a radius for it. So let's make a private float retreat position radius and say 5. And what that's going to do is it's going to make like a little circle with that radius around that position, and it's going to check for a nav mesh point within that circle. And if there is a viable walking nav mesh point, basically it's going to pass that check. So this is essentially just checking to see if we can literally walk on a nav mesh position at that point. If there's anything within 5 meters, I believe meters is the default measurement in Unity if you say 5, then it's going to be like, yep, we can do that. Whoops, didn't mean to write that. So it's going to be if sample position, and we're going to pass the random position, out hit, retreat position, and then we're going to pass nav mesh all areas. I don't think I need retreat path here. I'm looking at my code and getting my, yeah, I got that cross. That's my bad. So we just pass the random position, we pass the out hit variable, and then we pass the radius that we want to check after we get to that position for a walkable point, and we're going to check nav mesh all areas. So basically this is the radius that we're going to check once we get to that point. This is the position, the point that we're assigning. So picture a point in the map, and then at that point, picture a circle forming a radius, and we look for a nav mesh position within that radius. If that does pass, the retreat position is equal to hit.position. Otherwise, we have no walkable position. We just assign our character's transform.position. But there's a step further. So we want to check if that position, because you can hit a nav mesh area, right? But there might not be a way to walk to it. You understand what I'm saying? Like, let's say you scan a little platform that's floating in the air that has a nav mesh on it, but your character has no way to get to it. Well, let's do a calculate path. And we're going to say, if we calculate a path to this nav mesh, and we're going to assign the hit.position, we can then check to see if we can fully complete the path, or if we can partially complete the path. So we can say, if retreat path.status is equal to path complete, we know we can walk the full length of the path. But if we have it set to, I think it's called path partial, yes, then what we want to do is walk to the final end of the path, or the last point we're able to. So we're going to say, if we can do that, if we have a partial path and the corners.length is greater than 0, then we know we can proceed. Otherwise, for whatever reason, just assign the transform.position to the character. So let's see, if we get to the end of the path, we're going to say retreat position is equal to hit.position. If we can't quite make it to the end of the path, we're going to say retreat position is equal to retreat path. Then we're going to say dot corners. Then we're going to do some brackets here. And we're going to say retreat path dot corners dot length -1. And that will take you to the last possible position of the path. So if we can walk the full path, proceed to its end. If we cannot, proceed to its last walkable point. That's where you get the path partial thing there. And otherwise, just a catch here, just don't retreat at all. Use the AI character's transform.position. So make some comments here. There we go. And the last thing you want to do finally is return this retreat position, because we need to return something, as this is a vector 3. All right, cool. Now, you could make your own state for this, but it's also viable to put it on the attack state right after you perform an attack. You could say it is a part of the attack to shoot, retreat, and then kind of reset. Up to you, though. I have it on my attack state in Nef. So let's make a header for retreat, because we're going to need some variables here. Let's make a serializable field for a protected bool. And we'll call this retreat after attack. Defaultly going to set it to false so it doesn't break anything else you already have set up. And we're going to say pursuit mode, retreat speed. So you can make them walk away, run away, sprint away, whatever you want. And we'll put the default to sprint, just to cap it out. Generally speaking, when you retreat, you're probably trying to get out of there fast. Okay, and then we're going to have a minimum distance needed to retreat. So what does this mean? Basically, how close does the player have to be for you to start running away? If you're, 5 or less, sprint away. If you're 10 or less, sprint away. Basically, this number will be the minimum distance the character needs to actually run away. Next, we're going to have a private float for distance from retreat position. So this is how close we are to getting to the actual retreat destination. And default, we'll set it to mathf.infinity. Then we're going to do a private vector3. And we're going to keep a copy of our retreat position. Whoops, didn't mean to open up curly brackets, autocomplete. And we'll say it's by default at vector3.0. Okay, so over on our reset state flags, we need to remember to reset these things. Otherwise, the distance will be the nav mesh stopping distance, and we'll skip it if we've completed it at the time before we've come here. So just set distance from retreat position to mathf.infinity and set your retreat position to vector3.0. Make a serializable field for protected bool. Has retreat position, kind of forgot this, defaultly at false. And you don't really need to see this, so I can just get rid of the serializable field. Make sure you set that to false again though when you're leaving the state. There we go. And now we need to go over here on tick, and let's go to after we pivot, and we'll start here. We're going to say if retreat after attack, and we do not have a retreat position, then we want to get one. So we could say and the character combat manager dot distance from target is less than the minimum distance needed to retreat. So we only want to do this too if we're actually far enough away to retreat, or close enough rather. We're going to say has retreat position is equal to true, retreat position is equal to AI character combat manager get retreat position. Optional, check for it being damaged, and if you are, return to the combat stand state. This would essentially interrupt the retreat and cause you to go back to the state where you start attacking. Up to you, it's optional, it could be a fun little challenge. So we're going to say if has retreat position and distance from retreat position is greater than the stopping distance of the nav mesh agent, that is, then we're going to simply turn on the nav mesh agent, and then we're going to start running away. So we're going to say if AI character is performing action, we could say return this. Again, you could also just drop out of the state if you want to, or you could disable movement and then drop out of the state. And then we could say distance from retreat position is equal to vector3.distance, and then we're going to get the AI character transfer position and the retreat distance, or rather the retreat position. And then we're going to say enable the nav mesh agent on the AI character manager, and then we're going to say AI character combat manager rotate towards agent. Now, in my experience, you want to rotate towards the agent as fast as possible, so if you have some method that does that instantly, I think this one does, you want to use that. And then we're going to switch our retreat speed, do a switch statement, and basically for each of these, set up the speeds that you want. If we have it on none, it's still going to by default enable walking because the nav mesh agent has a destination. So we're going to say nav mesh path, and we're going to say this is equal to new nav mesh path. And then we're going to say AI character.nav mesh agent calculate path, and we're going to pass our retreat position and our path. And then we're going to say AI character.nav mesh agent set path, and we're going to pass the path. Now we're going to simply return this, and this should work, I believe. So let's go test. Go to your attack state and enable the retreat after attack, and set your distance like 2. We'll make it so they only retreat if they're closer to 2. So I'm going to set it to like 8 just for testing. If I go into the scene here through the magic of editing, you can see he's walking at me. Now watch, I'm going to come around the corner, let him take a shot, and now he should run away. Yes, there he goes. So you may want to enable pivoting there too, because that would just look a bit better, but it's entirely up to you. And right there, do you see how he does that little walk roundabout? So your choices there are to make the rotation speed very high, or to enable pivoting after each of these actions. Both are acceptable. In Nef, I prefer to use pivoting personally. So I can definitely jump on some other stuff. Somebody mentioned in the Discord they want to like backing away from the target as they fire the bow too, instead of just full on retreating. I can cover that if you want, and I can make it too so if we are backing up and we're about to back into a wall or walk off a ledge, I can show you how to not do that, because remember when we are in that whole like strafing motion set, we're not using the AI nav mesh agent to actually calculate a path. We're kind of just moving around using that. So I can show you how to check for a drop off, or I think we already checked what happens if you bump into a wall, but we can do that. If you'd rather see something else though, let me know and I will move on to something else entirely. Just leave some comments below, because right now we're going to try to bang out some cool AI functionality, because that's been requested for a long time. So we're going to keep on going with this for a while. Okay, everybody, thank you very much for being here. As always, you have my sincerest appreciation for your support on the series. A special thank you to my patrons and the people who take the time to like and share this video, to comment, and to share it via word of mouth. The series is alive and well because of all of you, and I feel very fortunate to be here. I hope you learned something, and I hope you have a very fantastic weekend. I'll see you guys next time.